Good morning, everybody. It's a chilly day in Northeast Indiana. You can hear the furnace going in the background, probably. And I'm too much of a softie to turn it down to do the video in a pretty cold shop. This is just going to be a short video about 6 splines. Well, any kind of spline, really, mechanical spline. But this is a non-involute spline. This happens to be a 1-inch 6 spline. It's an SAE standard. You can look up the dimensions in Machinery's Handbook or probably online. I'll tell you that I tried making it according to the dimensions in the Machinery's Handbook, and I think you're better off if you have an example of a spline that you want to fit. Just take some quick measurements and make it like that. The 1-inch 6 spline has a spline width of a 1/4 inch, and you can see that the sides are not radial. The sides are kind of parallel on the edge, like the two sides of the tooth or the spline are parallel. So that just takes a little extra fiddling to cut it. I'll show you how I set this up and how I ran it. So basically the setup for running this part, I put this end in an indexer, and I'll show all this. Put a center on this end. I thought I was going to have to support the center, but the fact is I didn't. It ran just fine without that. And well, let's just freeze this right here and skip the hand puppet show and go to a couple diagrams that I think will be more explanatory. Okay, let's do one of these pictures worth 1,000 words things rather than watching me fumble with hand puppets. So this solid line is what you're trying to do here in cross section. This is roughly a 6 spline. What I'm showing here are the dimensions, the rough dimensions for a 1-inch 6 spline. Obviously it's not to scale. So what you're trying to do is create these parallel sides, these straight sides. It's a so-called straight-sided spline. And I tried it a couple of different ways, and I ended up reworking some of my earlier failures, which came out okay. But here's the way I ended up doing it that I think works the best. So we're going to rotate this just slightly because I prefer to work on the sides rather than the top with a vertical mill. And this shows the kind of the schematic view or the artwork view of the end of a key slot cutter. So what I did was I touched off at the top of the blank diameter, the 1-inch diameter, and then I raised up the work. It's the half of the diameter less half the spline width. So you just do the math and drop it down like that, and then feed it in roughly 1/8 of an inch from the touch off point here. And then you run that part, or run that face, index the work stuff. You raise the work up the width of the cutter plus the width of the spline, and then you run the bottom face. So what you're left with after you've done that is something that looks like this. You've got these kind of faceted looking surfaces there at the root of the spline. And so what I did was make a third pass with this cutter. Again, you're seeing the kind of the end view of that. another pass with this cutter with the part in this orientation where I came in and cleaned up that facet at the root and took it down about 1/8 of an inch again, maybe a little bit more. It doesn't come out round like the official according to Hoyle's spline, but flat surface at the bottom. Honestly, I can't even really tell the difference looking at it. And I don't think there's any functional impact to that. So anyway, that's the kind of drawing view of what I did. And it's not rocket science for sure. And once I got the dimensions worked out, it fit together pretty well. Not a lot of slop. And this kind of mechanical component, everyone recognizes these from milling machines and things that have splines. Anything that has to transmit power while sliding or after sliding uses a spline of some type. So anyway, this wasn't a real big project, but I need a couple of spline shafts for the project that I'm working on that I'll tell you more about later. Well, this is the page from Machinery's Handbook that deals with SAE standard non-involute, so-called straight-sided splines. 4 spline, 6 spline. The next page there's 10 spline and 16 spline forms. And the design there, all the design numbers, based on my experience, should be treated with a certain amount of suspicion. Best to measure a practical part and make it fit that. This is my second pass at making a 6 spline. Cutting the bottom face. Top face is already cut. Last pass, straight down the middle, cleaning out the gullet. That's looking pretty good. Well, that looks righteous. We'll see. Well, there it is. All cleaned up and function tested. I have to say, this was an unexpectedly significant pain in the ass to make. I think it took me about 6 passes to get the geometry right. Just some simple things that I probably should have done right to start with. This is a spline cover. It's a 1-inch 6 spline cover from a Van Norman dividing head. That goes on pretty good. Decent fit. Not perfect, but you know, really all you're doing is driving stuff, and it doesn't matter if it's got a little bit of slop. So anyway, this is the first component of my new hobbing machine, the conversion of the Van Norman 22 to a kind of a full-on hobbing machine where hopefully I capture some of the learning and I'm able to design a little bit better machine with not as much complexity as the last one. Anyway, that's it for me today. It's been a while since I've put a machining video out. I hope you find this interesting and useful to some degree. Anyway, that's all for now. Bye. Well, thanks for watching. I appreciate your interest, and if you haven't subscribed, please do.